So now that we've seen the feasible region, the geometry of the problem, right, what it looks like in 2 dimensions, it's easier to talk about the sensitivity report, which is what we're going to do. So what we want to do now is talk about the sensitivity report that got kicked out. So how sensitive are the results to changes in the parameters? For example, we could change the value of the coefficients. So in the objective function, we had 8 and 5. What happens if we change those to something else? We could also talk about changes in the right-hand side value of a constraint. We had 1,200 pounds of plastic. What happens if it's only 1,100 pounds? What happens if it's 1,300 pounds? Things like that. So there are two ways to do this. One is trial and error approach. In other words, change the numbers and then resolve it. And then there's also analytic post-optimality method. And that's just a fancy way of saying read the sensitivity report. So that's what we're going to do first, is we're going to look at the sensitivity report and see what it looks like, and then confirm our suspicions from the sensitivity report by maybe resolving some of these. So we're first going to look at the sensitivity analysis of the objective function coefficients. So we had $8 and $5, right, in our objective function for the galaxy example. So a change in the coefficients in the objective function may cause a different corner point to become the optimal solution. Right now, it's the corner point where the, as we saw in the picture from the last video, is where the plastic and the labor intersect, right? Our sensitivity report shows us how much the objective function coefficients may change without changing the optimal solution point, which was 480, 240, right? 480 space rays, 240 phasors, holding all other parameters constant. So that means we can only change one coefficient at a time, and we're not changing any of the constraints or any of the coefficients on the constraints or anything like that. Now the value of the objective function would obviously change if we change the objective function from $8 to $9. If that's within the range of optimality that we're going to call this thing, then yes, we would make $480 more. Right? So how much the objective function can change without changing the optimal solution point of the 480, 240 is known as the range of optimality. Now Excel gives us the necessary values, but you have to do the simple arithmetic to get the range itself. So let's see. So we're looking at the top part here called the variable cells, and we see that the objective function coefficient was an 8 and a 5. And then we have an allowable increase and allowable decrease. All right. So the objective function coefficient for space rays could go all the way up to $10, and we'd still be producing 480, 240. All right. It could go down to $3.75, 8 minus 425, and we'd still be doing 480, 240. That's if we don't. We can only change that number 8 to something else. For phasors, we see that we start at 5. It could go up a lot higher, go up 10 and 2/3, and we wouldn't change our allocation of what we're doing. It could only go down to $4. If it goes outside that range, we have to resolve it to see what the new solution point is going to be. All right. So let's try this. So we have, here's our galaxy example that I grabbed that's on Blackboard, right? And let's I'm gonna copy this, and we said in our sensitivity report here, right, we could go up to $10. So let's just go to 9. It's within the range, and that's the only thing we're going to change, right? So obviously when I do this, the profit's going to go up, right, by $480. But let's zero this out and let's resolve it with these. And I'm saying what we should get is the same thing we had here, which is 480, 240. So we better get 480, 240. Right? So now data solver, because I copied the worksheet over from the one that we had solved before, it keeps all of that, all the solver parameters set up properly. So I should just be able to click solve and click OK. Look at that. It did 480, 240 like we thought. All right. Now, if we go beyond that, then if I go to $11, then I'd have to resolve it. So going to $9, I did not have to resolve it, right? I would know from the sensitivity report that if I only change that one number from an 8 to a 9, it's within the allowable increase, and these numbers will stay the same, 482.40. Right? So in a larger problem, this could be quite beneficial rather than trying to solve it again. Right? Now, what happens if I have more than one objective function coefficient change? So if they're both within their allowable range, that still doesn't mean anything. There is some other kind of 100% rule you could look at, but I'm not going to make you do that. Instead, if you have more than one change, the easiest thing to do, especially for the small problems that we are looking at, is to change the coefficients, the numbers, and rerun the solver. Right? So if I go back over to here, right, and let's zero this out, and let's change this to a 9 and a 6, right, so they both went up, and then solve it again. Will I get 482.40? In this case, yes, I do, right? That's not always going to be the case, right? In this case, it would, because it's going up. It's less than 100%, right? Let's try 11 and 6 and zero these guys out and solve it again and see what happens. Still getting the same solution, so that solution is somewhat robust, is what it's telling me, right? So again, it's better to, if both things change, to resolve it, right? All right, so now we're going to move on to looking at some other sensitivity analysis.